Okay, to start, let's propose the existence of a market multiple, MM, which is a function of time because it changes over time. This is different than a company's valuation multiple, which is denoted with a single M. We'll assert that if a company can grow its own M more than MM, it outperforms the sector or industry valuation trend, and it must create some positive intrinsic multiple expansion. However, if a company grows its M less than MM, it underperforms the market. It must suffer some negative intrinsic multiple expansion. To measure exactly how much, we define a new variable with the Greek letter mu. This is equal to the company's multiple divided by the market multiple at any time t. This effectively makes mu the company's discount or premium to the market valuation, and it means that we can define the company's multiple as the product of mu and mm. Now, the math in VC 104 showed that whenever you have a product like this, we can use a bit of calculus to prove that the change in the company's multiple is equal to the change in the market multiple times the average mu plus the change in mu times the average market multiple. When you add these two values together, you will get the company's delta M. If you want to prove that, just plug in a few values. For example, assume that M goes from 5 to 7x and MM goes from 10 to 12x. The numbers will always work out. Now, when you plug this delta M expression into the multiple expansion formula, you get two new value drivers: market multiple expansion, which is driven by delta MM, and intrinsic multiple expansion, which is driven by delta mu. These two value drivers always add up to the multiple expansion value that you get from the formula up top. The math is even easier over here in the logarithmic model. If the company's valuation multiple is equal to the product of the market multiple and mu, then M2 over M1 is equal to MM2 times mu2 divided by MM1 times mu1. This means that market multiple expansion is simply MM2 over MM1, and intrinsic multiple expansion is simply mu2 over mu1. These two value drivers, when they're multiplied together, they will always give you M2 over M1, which is the multiple expansion equity return multiplier.